In the next part of the lesson, we are going to find the different parts of an ellipse. So the center, the vertices, co-vertices, foci, and then domain and range. Okay. So to find all that information, we need to be able to know H and K, our A value, our B value, and our C value. So it's actually best to start by finding those and then figuring out everything else. So anytime we are finding the parts of our ellipse, we need it to be in our standard form equation. So that means that we need x and y squared over a number equal to 1. So if we notice for problem 6, we don't have it in the correct form. So for this one, we just need to make this number a 1. And to do that, we are going to divide both sides by this 225. And then we're going to reduce those fractions and see where we're at. Okay. So 25 over 225 is going to reduce to be 1, so x squared over 9. And then plus 9 over 225 will reduce to be y squared over 25, and then equals 1. So now it's in the form that we need it to be. So next thing we want to do is identify the direction. So again, we're looking for the larger number. So the larger number is underneath y, so this is going to be vertical. Okay. And then our center is h and k, so since we don't have any numbers with x and y, it's just 0, 0. And then, so our a squared is 25, so that means if we take the square root of each side, a is 5. B squared is 9, so again if we take the square root, our B is going to be 3. And then we also need to find C for if we're trying to identify the foci. So we're using the equation C squared equals A squared minus B squared to help us figure out C. So C squared will be 25 minus 9. So that is going to give us C squared equals 16, so then C would have to be 4. So again, we're using the A, the B, and our C now to find the rest of our information along with our center. So if we start with our vertices, so I'm just going to use V for vertices. Okay, we know that we're going to have 2. And we know that we're vertical. So what I'm going to do just to kind of help us picture what's going on is I'm going to just make a rough sketch of our ellipse. So since it's vertical, we know that it's going to be longer this way. And here's our random center point. Well, it's not random. This is at 0, 0. Okay. So our vertices are going to be above our center point and below our center point. And we know that our A value is 5. So this distance has to be 5. And then this distance has to be 5. So since we're moving up and down, we can just add and subtract 5 to the y value of our center. And then our x is going to stay the same. So this will be 0, 0. And then if we add 5, 0 plus 5 is 5. And if we subtract 5, that'll give us negative 5. And then our co-vertices, so I'm going to put co-B. Again, we have 2 of those points. So that's going to be this direction. So to here and to here, and that's the length of our B value, which we know is 3. Okay. So again, if we're moving horizontally, that means that the x value is changing. So we're just going to add and subtract 3 from the x value of our center. So we'll have 3, 0 for this point, and then negative 3, 0 for the second point. Next thing that we're finding is the foci. So again, those are points, and we have 2 of them. So the foci sit on the major axis, so it's going to be somewhere here and here. And we also found that that's our C value. So this distance is 4. So again, we can just add and subtract 4 from the y value since we're going up and down of our center. So x is going to stay the same, so 0, 0. And then if we add 4, 0 plus 4 is 4. And then if we subtract 4, that will give us negative 4. And then our domain, so again, we have a rough sketch right now. So the domain is in between the vertices or the co-vertices, so it depends on which way it opens. So domain is left and right, so that's going to be this direction. So our domain for this problem is going to be between our co-vertices, and we care about those x values. So it's going to be between -3 and +3. Oops, bracket for both. And then the range is up and down, so it's going to be between the two vertices, and we care about the y values. So from -5 to +5. And all of this would be our answer. All right, so if we go to the next problem, same direction. So and this one is already in the form that we want it to be in. So let's just start by identifying the direction. So our larger number is underneath our y. So this one is also going to be vertical. Okay. So again, it's going to look like this again. So in the center is h and k, so we're going to have 3, 2 for that. And then, so our a, so a squared is 128. So again, we would just start by taking the square root of that, which can be simplified. So we can divide, let's see, 4 goes in there, so it'd be 4 times 32. So let's see, 16 goes in there. Let's see, what else goes in there? 64, there we go. 64 goes in there. So 64 times 2. So that means that our a is going to be equal to the square root of 64, which is 8, and then square root of 2. And then our b value is going to be the square root of 36, which is 6. And then again, we're using this formula to help us find c. So c squared equals 128 minus 36. So 128 minus 36 is going to give us, let's see, 92. Again, we just want to take the square root of each side. 92. So let's see, 92, that would be 4 and 23, so this will be 2 square root of 23 for C. Oops, 23. Okay. So for the vertices, again, we have 2 of them. And let's see, let's draw just another rough sketch to help us mentally picture what's going on just a little bit better here. So again, we have a vertical ellipse, center in the middle, at 3, 2. And it's vertical. So that means our vertices are going to be up and down. So this distance is our a value, which we know is 8 square root of 2. And then the other way would also be 8 square root of 2. So from our center point, since we're going up and down, we're going to add this 8 square root of 2 to the y value, and our x is going to stay the same. So we'll have 3, comma, and then 2 plus 8 square root of 2. And then I'm also going to subtract it for that second point. So to shorthand it, we can write this as 2 plus minus 8 square root of 2, since we can't combine them like we were on this one. Okay, so again, this represents 2 vertices because of that plus minus. And then if we do the co-vertices, so that one we don't have a radical, so we're going to write it as 2 separate points. Okay, so b value is this way, which is 6. So again, this is our vertice, co-vertice. So since we're moving left and right, that makes the x value change. So if we take 3 plus 6, that will be 9, and then our y stays the same. And then we would do 3 minus 6, which is -3. And again, our x, so that would be on this side of it. And then our 2 stays the same. So next up we have our foci. So again, that's going to be 2 points, and we use C for that. And because there's a radical, we're allowed to write this as just 1 big point with the plus minus again. So again, our foci is going to be somewhere here, and this is our C value. So since we're going up and down, that means that we're going to add our C to the y value. So x is going to stay the same. So we'll have 3, comma, and then 2, so our center point, plus and minus our C, which is 2 square root of 23. And then the domain for this problem, so again, that's going to be this direction. So that's going to be between our two co-vertices. And again, we care about the x values. So it's going to be between -3 and +9. And then the range, so that's this way. So between our two vertices, and we care about the y values. So the first one we're going to do is the smaller number. So we're going to take 2 minus 8 squared of 2. So 2 minus 8 squared of 2, comma, and then 2 plus 8 squared of 2. And this one we can't write as 1 because remember we're talking about a range of numbers. Okay. All right, and that is going to conclude that problem.